Hey, what's up everybody? Mr. Klinkerman here. We have finally arrived. We're starting in section 2.6. That's not what I mean by we arrived. But what we have arrived at is we're going to be formally writing what are called proofs. And in particular, we're going to be proving statements about segments and angles, as you see from the title of the section. And there's one learning goal here, and that learning goal is this. We're going to learn to write what's called a two-column proof to prove statements about segments and angles. Now, a proof can come in many forms. In this lesson, we're going to learn two-column proof, which is a formal way of proving a statement about some kind of figure, in this case a segment or an angle. There's only one learning goal in this lesson. However, I am going to make a second video just because now that we're introducing you formally to proofs, it makes a lot of sense for you to see as many examples of those as you can. We are going to spend a couple days on this section. Alright, well, don't want to spend much more time with background information. We need to get right into the content here. One of the things that goes along with two-column proofs, well, just the idea of proof at all, is that now we're going to be starting to work with theorems. You're going to be introduced to your first theorem right now. And as you may recall, a theorem is a fact that's accepted because it's able to be proven. It's true because you can prove that it's true. Alright, so far we've worked with properties and postulates. Remember, postulates are facts that are accepted as true without being proven. Alright, a theorem you've got to prove in order to use it. And theorems can be about a lot of different things. It happens that this one is about segment congruence. And it's very related to what the properties in the previous section were that we were learning. Theorem 2.1 states this, that segment congruence is reflexive, symmetric, and transitive. Alright, reflexive, symmetric, and transitive. We just learned the reflexive, symmetric, and transitive properties in the previous section, 2.5. And what we said there, in terms of segments anyway, was that the distance between 2 points can have the reflexive property, the symmetric property, and transitive property, depending on how many distances you're comparing with one another. Okay, now that is a little bit different than these properties for segment congruence, and I'll try to explain that. But here is what we're saying when we say that segment congruence is reflexive. No matter what segment you're talking about, A, B, any segment is congruent to itself. All right. Now, we're not saying a distance is equal to itself, not directly anyway, but what we're saying is that the segment is exactly the same size and shape as this segment would be. Alright, any segment is always congruent to itself. That's a super important property for the proofs that we're going to write, especially involving triangles in later chapters. Alright, and then the symmetric property. Well, if you have two segments A, B, and CD, if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. Alright, not going to elaborate on that one too much, although we're talking about theorems being statements that you can prove. We're not going to prove this entire theorem, but we're going to prove this particular statement right here in just a moment, the symmetric property portion of Theorem 2.1. Also, segment congruence is transitive. If I know that segment AB is congruent to segment CD and segment CD is congruent to segment EF, or in other words, that segment AB and segment EF are both congruent to the same segment CD, then segment AB has to be congruent to segment EF. Alright, you're familiar with how those properties work. It's just now that we're talking about congruence instead of equality. Alright, there is a difference there. Alright, I told you we're going to write a proof here. Now hopefully within your notes you're copying all this stuff down anyway. This is what a two-column proof is going to look like, okay? And what we're going to do is what I said a moment ago. We're going to write a proof for the symmetry of segment congruence. And whenever you write a proof, there are several things that are always included. Alright, one of the things generally is you have a picture. And that picture is supposed to just give you a general idea of how you can apply properties or postulates or other theorems as a part of your proof. It allows you to examine relationships between segments and angles and whether you have parallel lines and all that kind of stuff. All right. Anyway, there's a picture there to aid us. That's what it's for. And then here, this is always key. In a proof, you're always going to have something that says given. And you'll have a statement or several statements following given. And what the given part is this is a list of things that we can assume are facts for this problem. So in this problem, we're going to assume that segment JK is congruent to segment LM. And then, along with your given statement, you're always going to have a statement that you're trying to prove. In this case, we're trying to prove essentially this, that if segment JK is congruent to segment LM, then segment LM is congruent to segment JK. I hope you recognize that as the symmetric property of segment congruence. All right, and then in the two-column proof format in particular, you have two columns. Hey, who would have guessed that? And in the left-hand column, which you always label as statements, here's where you're gonna write a logical argument. You're gonna put in a logical sequence the statement of facts that lead you from this statement, that segment JK is congruent to segment LM, to ultimately being able to make this conclusion that segment LM is congruent to segment JK. And in the second column, the reasons column, what you're going to do is you're going to write down any postulates, theorems, or properties that justify the corresponding statements that you make in your proof. Okay, now very important, you need to know, have in your arsenal, a lot of theorems, postulates, and properties as well. And I'll talk more about that as we go. But I want to go ahead and get into this proof right here. Now, the first step in any proof is pretty simple, to be honest. You always start off by stating that one of your given statements is true. If you have more than one, then you pick one of them. All right, and the first thing that we know here is that segment JK is congruent to segment LM. So I'm going to write that there. All right, now I want to talk to you about a strategy for what it is that we're trying to accomplish right here. And that strategy is going to go like this. We've got to figure out how does this fact ultimately imply that this is also a fact. Now, I hope you're thinking that in this case it's obvious that if this is true, this is true. This is a very basic proof that we're doing here. But nevertheless, we've got to come up with a series of steps that are justified in order to make that statement true. All right, so what do you know about two segments that are congruent to one another? Well, what you know about two segments that are congruent is that their lengths are equal to one another. So we're going to be able to say that the length JK equals the length LM. How does that help us to prove this? Well, if the length JK equals the length LM, according to the symmetric property of equality, not congruence but of equality, that would mean that the length of LM is also equal to the length JK. And if the length LM equals the length JK, then we can say that segment LM is congruent to segment JK. All right, that's where we're going with this. Now let's watch the actual proof. I said that the next thing that we're going to do here is we're going to say that since segment JK is congruent to segment LM, that the distance from J to K is equal to the distance from L to M. Now notice whenever I'm trying to write either a congruent statement or an equation with segments or distances involved, if I ever use a congruent symbol, I always have the name of the segment. I always have the segment symbol above. All right? But if I don't have the little congruent symbol, in other words, I don't have that wavy line on top of my equal sign, then I also don't have the segment symbol above the name right there, because that's referring to a measurement. It's not referring to the name of the segment anymore. All right, it's a very important detail to catch on to. Well, how do we know that when two segments are congruent that their lengths are equal? That's by the definition of congruent segments. If two segments are equal, then they have to have, sorry, if two segments are congruent, then their lengths must be equal. Alright, well, if the distance from J to K is equal to the distance from L to M, then the distance from L to M has to be equal to the distance from J to K. And we know that because what we just learned is that for equations, you can essentially switch what's on one side of an equation with what's on the other side of an equation, and the two sides will still remain equal to one another. That was the symmetric property of equality. Okay, the symmetric property of equality has to do with equations. Symmetric property of congruence that we're proving has to do with congruent statements. There is a difference there. All right, finally, if I know that the distance from L to M equals the distance from J to K, well, that makes those two segments congruent, doesn't it? So, segment LM is congruent to segment JK. That's supposed to be a wavy line. And how did I know that those segments were congruent to one another when their lengths were equal? Well, again, that's the definition of congruent segments. If two segments are the same length, then they are congruent to one another. All right, there's your first formal proof. I hope that you have some questions that you're going to ask in class, whether we get to ask them as a whole group or whether you ask them individually. But come up with anything that you didn't understand conceptually and make sure that in terms of proofs and ask me about it. Okay, now we've got another theorem to talk about and then one more proof that we're going to do within this video. And the next theorem is essentially the same thing that we just looked at in Theorem 2.1, but it's with angles instead of segments. And so we'll go through this kind of quickly. Theorem 2.2 states that angle congruence is reflexive, symmetric, and transitive. So, for any angle, the angle is congruent to itself. If you have two angles A and B where angle A is congruent to angle B, well then angle B is congruent to angle A. Alright, so this is saying with congruent statements that you can switch what's on the left side with what's on the right side and it's still a true statement. Alright, that's an important fact to know. And then the transitive property, if angle A is congruent to angle B and angle C is also congruent to angle B, then angle A and angle C have to be congruent to one another because they're congruent to the same angle. All right, there's the transitive property. Now, yes, this is a theorem, and yes, each of these statements can be proven. And at least one or two of them you'll be proving within homework problems. I'm not going to take the time to prove these things because they are fairly obvious, I believe, and I want to spend our time with proofs proving unobvious things whenever I possibly can. Alright? Or less obvious things. I shouldn't say unobvious things. Now, here's going to be our next proof. I need you to copy down all of this information. You've got to always have a given statement and a proof statement. You've always got to have the picture included. And you've always got to have your columns labeled with statements and reasons. If your paper does not have all of this stuff exactly the way that I have it, then you're doing something wrong. All right, follow my example here. Copy that down, please. All right, you should have had time to copy everything down by now. Let's go ahead and talk a little bit of strategy here. What we're trying to show here is that if angle 2 is congruent to angle 3, all right, if this angle and this angle are congruent, then angle 1 has to be congruent to angle 2 as well. All right, and we'll talk about why that has to be true here. All right, but if angle 2 is congruent to angle 3, ultimately we want to prove that angle 1 is congruent to angle 2. Now I'm going to go ahead and start off the proof a little bit just because you hopefully know what's going to go first. We're always going to start with our given statement. So let's say that angle 2 is congruent to angle 3. And the reason we know that's true is because it was given to us in this problem. Now we have to formulate a strategy, a series of conclusions based on that statement that will lead us to ultimately prove angle 1 is congruent to angle 2. Alright, now I want to talk about the diagram for a moment. One of the things that you're going to do with the diagram is you're going to formulate a strategy. Alright, and in this case it's more applicable than it was in the previous proof that we did. We were just told that angle 2 is congruent to angle 3, and so I'm going to go ahead and mark that angle 2 is congruent to angle 3. And we got to formulate our plan as to how we're going to then show that angle 1 is congruent to angle 2. Well, you ought to know that there's a certain relationship between angle 1 and angle 3, right? Aren't those vertical angles? And haven't we said that vertical angles are always congruent to one another? So, using that fact, we're going to be able to prove that angle 1 is congruent to angle 3. And then if angle 1 is congruent to angle 3, and we already know that angle 2 is congruent to angle 3, that would make angle 1 and angle 2 congruent to the same thing. And so by the transitive property, they would have to be congruent to each other. Alright, that's the way this proof is going to go. So listen and watch as I write out the statements here. Alright, I said that the next part of our strategy here is that we're going to show that angle 1 and angle 3 are congruent to one another. And so I'm actually going to make that statement in my proof right now. Angle 1 is congruent to angle 3. And how do I know that angle 1 is congruent to angle 3? Well, because I know that vertical angles are congruent. By the way, the fact that vertical angles are congruent is something that's provable. We've kind of informally done that in class before, actually made that proof. In the next section then, we're going to actually prove that fact, and that's going to be a theorem called the vertical angles theorem. But you don't have to know the name of the theorem. All you have to do is write the fact that vertical angles are congruent. Alright, and since angle 1 and angle 2 are each congruent to angle 3, we can prove that they are congruent to one another by the transitive property of congruence. Alright, so we're already ready to go ahead and make that final statement in this proof that angle 1 is congruent to angle 2. And that involves that theorem 2.2. In particular, that angles, or the angle congruence, is transitive. I tell you what, I'm going to write that differently. We are using the transitive property of angle congruence in order to justify that fact. Great. This has been a brief introduction to proofs. Hope it's made some sense to you. And let's just keep building. It's logical, so it should make sense, right? Let's keep building on this idea and have a lot of good times proving things this year. All right, I'll see you later.